Okay, hi everyone. I'm Wout, and today I'm here to talk about our FrankenBatch project. Last year, I talked here about how we use data contracts into streaming pipelines. This year, I'm going to talk about how we use it for upgrade of our legacy data pipelines. So the focus will be on batch pipelines this year. Our legacy data warehouse looks a bit like this. Actually, I'm working as a data engineer for Veepee, which is a retail company, and we have online flash sales. And for us, it's very important to provide a lot of data to analysts. So that's my main responsibility. Make sure that that analysts can find data into BigQuery and use it like self-service wise. Our current mechanism to get this done is a nightly ETL job. And it will transfer the most important tables from SQL Server into BigQuery using Pig. I'm curious, is there anyone in the audience who knows Pig? Raise your hand, please. Is there anyone still using it? No one? Yeah, you see, that's why we want to get rid of it. We really want to upgrade it. So to give an example, right now in Airflow, our DAG looks like this. And this is only for 5 or 6 tables. So it's not very pretty. It's quite hard to maintain. But anyway, it's been doing the trick for over 4 years, which is great. And ever since our data is in BigQuery, our analysts love it. They can query data easily. There's good integration with G Suite. And also our clickstream data gets streamed into BigQuery, so they can join it and figure the stuff out they want to do. However, like the Pig scripts are very table-specific, the transformations, so it's not nice to maintain. Right now, we only do nightly transfers, and those nightly transfers are snapshots. So we only get like daily changes. And also, this nightly batch, it puts load on our production database, which is not good. Like it's something you should never do. And that's also the reason why we only transfer the most important tables right now. And for us, those tables are, for example, cards, users, sales, etc. So we decided to fix it up, the system, and we're going to do it with batch pipelines. So we decided on the name FrankenBatch. We want to keep it alive. We want to keep the monster alive. Only for a couple of years, though. Like it's a business decision that they're only going to use it for a few more years. It's not like we're starting from scratch, but we just want to patch it up. And to see what we could improve, we asked analysts what they valued. And they told us, yeah, hey, we would like to have data like all in one place. Right now, they have to query some tables on SQL Server, some tables on BigQuery, which is not nice at all. Next to that, they want to have change history, and not only daily change history, but like if multiple changes happen on a certain row on the same day, we won't see it in our current data warehouse. So that's something they value. And also like more near-time updates. The frequency should be a bit higher. Hourly will suffice. And right now it's nightly. So yeah, that would be great. Then we also thought about what we value as data engineers, and to be honest, we're quite lazy. So we like minimal maintenance. We don't like to do a lot of manual stuff. And when someone changes something in the production database, like adding a table or adding a column, we also don't want to do some manual intervention, and we don't want to be aware of it all the time. We just want to build our system this way so it will take care of it by itself. So to achieve this, we made three big design decisions in our system. And the first one is that we're going to use change data capture, also known as CDC. And this is a feature that's supported by SQL Server. And what it does is that when it's enabled on the database for a specific table, it will create a system table. And in the system table, it will keep track of every change of every row. So the operation is kept track of, and the timestamp when it happened as well. So there's an example down below of our order table. And as you can see, there's like one insert statement and 2 update statements. The first insert and the first update, they occurred on the same day. In our legacy warehouse, which we currently have, this update wouldn't be visible. So like the state change from incomplete to pending payment wouldn't be visible. And this is something that we really want to provide to our analysts. Like it goes away in our current solution. So CDC can help us with that. The next design decision, which we made, is to use data contracts. And what we basically are going to do is to generate ProtoBeam contracts from our SQL schemas. And later on, from those ProtoBeam contracts, we're going to generate BigQuery schemas. And we do this because this way we make our schema evolution a bit more manageable. So we can easily update our BigQuery schemas accordingly when the ones in the SQL Server change. And we also make it visible. So we will store our contracts in a Git repository. And as you can see in the example below, like there was a column added, shipping fee, and we can see when it happened. So it makes it a bit more manageable for us as data engineers, as we do not have any control over the production database. Then the last design decision that we made is that we're just going to keep using batch instead of streaming. This has a few reasons, and the first one is that it's like easy to query rows for a specific interval. If you see the example below, it's an interval of an hour. We can easily specify it, and like the query stays more or less the same. We just need to replace the interval. Then, if something goes wrong, we can easily replay it. With streaming, it's much harder to figure out which parts you need to replay. And yeah, also, hourly updates, they will suffice for analysts. As streaming, like really real-time updates for analysts do not provide real business value right now. Like hourly updates will suffice. That's why we decided to go with batch, just keep it simple and not overcomplicate stuff. We also already had like plenty of experience with batch pipelines, so we went for that one. So to come to our setup, as I already said, our SQL server, our production SQL server, we also didn't want to put load on it. So we decided to make a replica out of it, so it gets synced automatically. It's also a feature of SQL Server, so it comes out of the box. And when we enable CAC on the replica, those tables I was talking about, they appear in the SQL Server. Now, basically, all we have to do next is use an hourly Beam pipeline and load them into BigQuery. So this is quite straightforward, very simple. But we forgot about one thing. And something that we need is one way to make sure that we got all our resources right. So we created this FrankenPrep microservice, which is responsible to generate our schemas. So it's the generate step. It will convert the SQL schema into ProtoBeam contracts. And it will also have an ensure step. And there it will create BigQuery tables. We'll make sure their schemas get updated. It will enable CDC on the SQL Server. And it will make sure our tables get filled up before we start. So it will pre-populate them. To go more into depth on this one, like if there's a call to FrankenPrep to generate the contracts, and this call will be made by our build system. So it's triggered when the SQL schemas might have changed. Then the first thing FrankenPrep will do is to fetch the metadata from the table schemas. Using this metadata, it will be mapped to proto contracts, and we do this using the Java proto descriptor API. It's quite easy to really create a proto descriptor file telling like which fields have which types. And then we convert them to proto files using the descriptor, and we store them in a Git repository. And we only commit when there are any changes to our contracts. So this happens quite often. When something changed to our production system, the generate gets triggered, and we get the newest contracts in our Git repository. We do this for every table in SQL Server. So for every table, we will get like a contract, and it's quite nice and manageable. Get it in a Git repository, and we use it on GitLab, so we can easily run some CI/CD on this. And in this CI/CD pipelines, we compile our protos, to make sure that the protobuf that we put in there, that it works. And once it's compiled, we compile it to Java. We bundle them and we publish it as an artifact to Maven. So we can later on use those in our batch pipelines. Then I talked about the generate step. Now I'm talking about the ensure step. And now to specify which tables like analysts really want to see into BigQuery, we use a config file. So we specify all the tables in there. And the ensure step basically runs this pseudocode. So for every table in the config file, it will check with SQL Server if CDC was already enabled. If it wasn't, it will enable CDC. So it will start creating system tables, keep track of all the changes. Afterwards, we will create a BigQuery table using the contract that we had. And we will pre-populate it by spinning up a Beam pipeline. And that's just loading all the data that was already in the SQL Server into BigQuery. If CDC was already enabled, then we're only going to try update the schema in BigQuery using the BigQuery API. So just as an overview, like we put the FrankenPrep service next to the other setup. And as you can see, we just get the schema and we ensure the tables in BigQuery. Now there's one part of this thing I haven't talked about yet, and it's the hourly Beam pipeline. So let's have a look at that. And it's also pretty straightforward, actually. So what it does is that it uses the GDB-CIO to read rows from SQL for a specified interval. Then we get like the SQL rows. And we're using the data contracts. Like from the data contracts, we get these Java classes that match our schema. And we populate them with the values that we find in the SQL row. So we cast all the values, make sure it gets populated. And once we have those populated objects, we can easily convert them into table rows, which BigQuery will use by using the ProtoBeam project. And I don't know if you've seen the keynote earlier today from Alex. He talked about our ProtoBeam project. And basically what it does is to convert like proto files into table rows. And it does also support for other technologies. So we just use it here out of the box. He's also about to make sure the ProtoBeam gets included in the Beam code base, so it would be really nice. And also to let it work with schema-aware peer collections. So this pipeline, it gets rebuilt every time when the contracts change or when the pipeline changed. And like every time when we build it, we make sure that the latest contracts that we publish to a Maven repository are included. So we're sure that the pipeline always is up to date with the schemas that are in SQL and the schemas that are in BigQuery accordingly. We schedule this in Airflow, and so we trigger it hourly. And also that we just trigger one pipeline actually each hour. And we parallelize all the transformations for our tables. So we just need to spin up one data flow job. And yeah, you can easily put them next to each other. So then our data is in BigQuery. And because we use ProtoBeam, we get something extra as well. And that's that we can tweak BigQuery a bit for the likes of our analysts. And Alex also touched on this earlier today very briefly. So because we use those contracts, we can make use of protobuf options, and you can define custom options. So for ProtoBeam, we define some custom options to be able to rename certain fields in BigQuery. So when we set the rename to field and we make it Pascal case instead of snake case, it gets reflected in the table schema in BigQuery accordingly. We also do put some other options for time partitioning, for example. But I won't go into depth on this, but it can be really useful. Another thing to note, and that analysts kind of like, is that once the raw CDC data is in BigQuery, we can easily build views on top of that to get the latest state and to get them really working with the data they want to. And then last but not least, something very important that we did was also to make sure that all the rows get transferred correctly. We wanted to build some confidence. So what we do is that we run count queries as well as on SQL Server as on BigQuery. and we compared accounts just to make sure that every row got transferred correctly. And this was quite useful, actually, when debugging as well. So we put it in a small dashboard. So the diffs should be 0. So right now, everything's OK. When something's wrong, when the counts don't match, the graph will go up. And that's something that happened when we just deployed our system. And this was because most of the data in our SQL server was in local time. And we're based in Brussels, so this was GMT +2 or +1. And like in BigQuery, we wanted everything to in UTC, of course. So when running the count queries, we saw that the stuff wasn't matching up. So we fixed it, and now it's running OK. So to summarize, like when we asked on what analyst value, we made change history possible by using CDC, SQL Server. We used hourly pipelines to make sure that the data was like updated every hour. And for us as data engineers, data contracts really enabled us to like have minimal maintenance to make sure we don't have to do manual intervention and just let the system run how we wanted it. Then also some takeaways from doing this project. I think it's a good idea to listen to analysts. Like for us, it provided us some focus on like what they value. They're our users. So, and as the system still has to run for a couple of years, it's them that need to use it mainly. Then don't overcomplicate things. Actually, we built a system in a couple of months. Like, wasn't that hard. If we would have done it streaming, it would have been way more complicated. So don't overcomplicate things when you're sure that it will not add any business value at all. Then what was also quite nice is that we made the system easily redeployable. Also by having the data contracts, we could recreate the tables easily. We could spin up the microservice, deploy it. It was quite useful. And last but not least, we built confidence by implementing data completeness checks, which was also very worth it. So yeah, this was our project. Thanks a lot for your attention. And if you have any questions, please shoot. No questions? Okay. Yeah. Wait, I'm gonna give you the mic.
What would you do, for example, if you have two protobuf inputs in your Beam pipeline, and then the output is something that doesn't have a protobuf, but you still want to use these serializers to table row? So do you then create, because you know what will be the intermediate step, do you create for it a protobuf, or how do you serialize to table row?
So to move from protobuf to a table row, we use the ProtoBeam project. Okay. And in this ProtoBeam project, we made like very clear steps, like this kind of data type gets casted to this kind of data type. And that's something that we moved outside of this project.
Okay, but when you're intermediate step, like, okay, it's okay for input source. You know what, you have two tables, you will create protobufs, and then you will have these serializators to table row. But imagine that you join two of them, and then you need to do something third and save this to table row. What are you going to do with these intermediates class?
Yeah, like we don't really have something intermediate like that right now. But like for us, we abstracted it away because the intermediate stuff that we like to do, we want to specify it. We want to put it in a configuration, which is like the renaming we talked about, like the time partitioning. There are some other options as well. And we want to, like, most of the stuff you want to do between the contract and the table row is just tweaking BigQuery a bit. So it's quite generic operations you want to put on that. So we try to put it into a config file. I don't know if it would work for joins. It's interesting, maybe.
Can I add something?
Yeah.
Just like ProtoBeam is really focused towards ingestion, and that's why it's but like there is like the movement for going to the schema ORP collections, and hopefully as much as possible of the metadata moves along the pipeline, and that will help. So let's work towards the future.
Okay. Some other questions? No one? Okay, thanks a lot, guys.